Welcome to Calc Chats 38. Today we're going to be talking about how to find the area between two curves. First, we need to recall that integration is what helps us find the area underneath a curve, or between a function and the x-axis. So if we were given a parabola, and that's a beautiful parabola, let's say this is y equals x squared plus 2. If I was asked to find the area from -1 to +1, all I would need to do is take the integral from -1 to +1, x squared plus 2 dx. And that will get me the area underneath the curve. What we're going to kind of be dealing with today is when we have multiple functions. So let's say we were given, again, the function y equals x squared plus 2, and let's give ourselves the function y equals -x. And we were asked to find the area between those two functions from -1 to 0. So first thing we're going to do is we need an integral from -1 to 0, but I want kind of one cohesive integral to look at. And what we really want is this area kind of in the black, right between those two curves. And so if we notice, if we can find the area of our parabola, that would get us all the way to the x-axis. And then alongside there, if we had our y equals -x, there's a little bit of area below that x-axis as well. And so what we can do is we can take the area under the curve of the parabola and subtract the area under the curve of the linear equation. And when we subtract that, that gets us just the area in between the curves, so just this area right here. And so what we're going to do is, if we notice our parabola is on the top, we're going to take the integral from -1 to 0 of x squared plus 2. Here, let me rewrite this integral where we have more room. So the integral from -1 to 0 of x squared plus 2, and we're going to subtract -x. And when we take that integral, this is going to allow us to find the area between the two curves. So the idea is that we're subtracting our top function minus our bottom function. So here we're given a similar scenario. We're asked to find the area bounded by y equals 3 minus x, that's in the red, and y equals x squared minus 9. And so again, since we're finding the area between two curves, we want to subtract the areas from the top curve, or of the top curve from the bottom curve. So our top curve is y equals 3 minus x. Our bottom curve is y equals x squared plus 9. Or sorry, minus 9. And in this scenario, we are not given any bounds, but if you notice, these two functions naturally create bounds between them. And so what we're going to do is, in order to, before we can solve the integral, we need to find those bounds. And we're going to set 3 minus x equal to x squared minus 9, and that is going to help us find our two bounds. So all I'm going to do is I'm going to move everything over to get x squared plus x minus 12 equals 0. So I get x plus 4, x minus 3. So my two bounds are -4 and +3. And so that's where, those are the sections where my graphs intersect. So I know my integral is going to be from -4 to 3. And then, like we said, the top function is y minus x, and our bottom function is y equals x squared minus 9. So altogether, our integral is going to look like the integral from -4 to 3 of 3 minus x minus, and then parentheses are important. Remember, we're taking the whole function minus 9. And so I'm just going to integrate these. I'm going to kind of combine like terms before we integrate. So this becomes negative x squared plus 9. So we get negative x squared minus x plus 12 dx. So we get negative x cubed over 3 minus x squared over 2 plus 12x from negative 4 to 3. And then we just use the fundamental theorem. 3 cubed over 3 minus 3 squared over 2 plus 12 times 3 minus negative 4 cubed over 3 minus negative 4 squared over 2 plus 12 times negative 4. And if you want to use a calculator to solve this, or you can just keep it in a fraction form, you should get 343 over 6, or 51.6, or sorry, 0.1667, rounding up. So here's another example, finding the area between y equals x squared and y equals 2 minus x squared for x between 0 and 2. So my shaded region is going to be kind of a little different. And so I'm going to draw my cutoff points at 0 and 2. And my shaded region are these two sections. And so what I noticed with this is I know that my bounds are between 0 and 2, so that's not the hard part. But what I have happen here is at this intersection point, both of my functions switch. So the top function becomes the bottom function, and the bottom function becomes the top function. So I know that since they switch, I actually do need to find that intersection point. But this one's pretty easy. We just set 2 minus x squared equal to x squared. So we get 2x squared equals 2. So x equals plus or minus 1. Obviously, since we're between 0 and 2, this has to be positive 1. So we're going to split up the way we take our integral. So from 0 to 1, our top function is 2 minus x squared, and our bottom function is x squared. And then we're going to add on the integral from 1 to 2, where our top function is x squared, and our bottom function is 2 minus x squared. So now when you integrate this, your kind of simplified version should be 2x minus 2x cubed over 3 from 0 to 1, and 2x cubed over 3 minus 2x from 1 to 2. And I'm not going to solve this out all by hand, but you should get 4 if you're doing that at home by yourself. For this next one, we're asked to find the area bounded by the graphs of y equals 2 minus x and y equals x squared, as well as y equals 0. So that's our x-axis. So just initially looking at this graph, we kind of notice that there is really no kind of top and bottom function, because both of my functions come together at one point. So it looks like y equals x is kind of the top function, but then it changes to y equals 2 minus x. And so we can't really integrate this in terms of x. Well, we could, but what we're going to learn is that it's going to be a little bit easier to integrate this in terms of y. So what we're going to do with this function is kind of flip it over and look at it in terms of y, because that's going to be a little bit easier for us to integrate. So what I did here was I kind of flipped and rotated my function to reflect what it would look like in terms of y. And here I can see a lot easier that my top function is y equals 2 minus x, and my bottom function is y equals x squared. Now the issue that I'm running into is I need to integrate these, like I said, in terms of y and not in terms of x. So my top function becomes x equals 2 minus y, and my bottom function becomes x equals the square root of y again. So I'm kind of turning them a little bit and rewriting them. And so now my top function is my linear still, my bottom function is my parabola, and I'm going from 0 until this intersection point right here. And so now that we have things in terms of y rather than x, we can solve for that intersection point. So we can take 2 minus y equals the square root of y. And so in order to solve this, we would need to square both sides. And since I really want you guys to focus on the integration rather than this whole process, I'll just tell you automatically we get y equals 1. And so now my bounds are from 0 to 1. My top function is 2 minus y, and my bottom function is the square root of y, and I'm integrating with respect to y. And so again, we're going to go through this entire process, integrate and evaluate our bounds, and at the end we should get 5 over 6. So here's a DIY problem. I kind of drew the graphs for you. So you're given x equals y squared and x equals 2 minus y squared, and you're asked to find the area between the graphs. And so this is, the other one was kind of less obvious, but when things are already in terms of y, this we know we need to integrate with respect to y instead of x. So that's kind of your big clue right there. So go ahead, pause the video, try it yourself. I'm going to take a minute to write down the solution, but go ahead, see how far you can get. All right, so here, first step is we have to find our bounds. So we get y equals -1 and y equals +1. And from there, we take our top function, which is 2 minus y squared. We subtract our bottom function, and you should have gotten 8 over 3. So now here are your ABC problems to try. For these problems, please make sure you try them all. For class, we're actually going to go through these problems before we move on to the circuit. So if you already have everything done, you'll be able to move on to the work. But if you don't, then you'll have to finish these before you move on. So go ahead. A is find the area bounded by secant squared and sine from 0 x equals 0 to x equals pi over 4. I didn't have the pi button on here. That's pi over 4. B is find the area enclosed by y equals 2 minus x and y equals -x. And then find the area between y equals x cubed and x equals y squared minus 2. So here are your answers. A is root 2 over 2. B is 9/2. And for C, it's about 4.21. You actually had to use a calculator to find one of those intersection points. So if you don't have a calculator, and that's the reason why you weren't able to solve it, that's fine. You'll have time in class to kind of go through it. So make sure to make note of any questions that you have. And thank you for watching, and be sure to like and subscribe.